let's say 7x plus 2x. Those are like terms because they both have a numerical value, which is here or there, whatever, and they both have an x. Really looking for like terms, all constants, all numerical, just straight values, 7, 2, 5, any number or set of numbers can be added together. When you look at terms, it's really more about what variables are in there. These two terms have the same variable of x, and they have the same exponents. Both of those exponents have an exponent of 1. Now, if I were to make this 7x and this 2x to the fourth, these are no longer like terms, even though they have the same variable. You cannot have different powers on those or different exponents. So, like terms have to have the same variables in them, and each of those variables must be raised to the same power. Now, what is a term? A term is a number, like 7 plus 2x. Let's go to that. I dropped the x there. That's a term. Okay, a term is a number, or just a variable, or a product of a number and a variable, or even a couple of variables. 2xy, that's a term. 2x, that's a term. Just 2 alone, that's a term. And now these are like terms, and that becomes 9. So terms are numbers, or a number, a variable alone, or the product of a number and one or more variables. And when you're looking at a polynomial, or when you're looking at an expression, the terms are separated by addition and subtraction. So just look for the plus signs. On each side, you'll have a term, and you're good to go.
And we want to gather together like terms. We have a look. These are all like terms. They all have a. So 2a plus 3a plus a is going to give us 6a. That's like having 2 apples plus 3 apples plus an apple. We get 6 apples altogether. We would never say that we get apple 6. That's why we never put the letter in front of the number. Okay. So let's get rid of that. Okay, moving on to our next problem. Here we've got a mixture of letters. I've got 5a plus 2b minus 2a plus 3b. So let's tackle the a's first. Here I've got 5a minus 2a. That minus belongs to this term here. So altogether, I've got 3a. Okay, now let's have a look at the b's. I've got 2b plus 2b plus 3b. That gives us 5b. So plus 5b.
For the plus signs, on each side you'll have a term, and you're good to go. So let's do some examples. So we have 4b minus b. Now, in regular practice of algebra, whenever you have just a variable with nothing in front of it, you might want to slip in a 1 there, just so you can see that numerical value. And you could very well just look at this and go, well, 4 minus 1 is equal to 3b. And that is certainly fine. And I'm sure that any algebra teacher would be happy, or algebra 2 teacher would be thrilled with you just doing, okay. So let's do our next example. We have 5x plus 7 minus 2x. Okay, so we have like terms of 5x and 2x, but they're separated. Now, you have a choice. You can just move the terms around and put those x terms together, which I'll do in my first example, and then I'll rewrite this, I think, and show you another way of writing it. And it's going to look like this. It's going to be 5x, negative 2x, and then plus 7. Now you might be going, but that's subtraction, and subtraction is not communal together, and I'm moving the signs with those terms. So I have positive 5 and negative 2x, these are like terms, and what I'm going to do for the rest of this video is I'm going to just use different shapes around the like terms to show you what I'm combining or adding together. So we have 5x minus 2x, 5 minus 2 is equal to 3x, and then we have a plus 7, and that's done. You've simplified the expression. Now it is simplifying, there's no equal sign, this is not an equation, so we're not going to find out what x is, we're not going to say x is equal to 5, and this is not evaluating, so we're not going to get a numerical value in our last line of work. It's not going to be like the answer is 10, or, because it looks like 3 plus 7 is equal to 10, but this has an x and this doesn't, so these are not like terms, these are not going to go together. This is it, this is your answer. So when we get into algebra, every time we work with a problem, we don't necessarily get a numerical value as an answer. When we solve an equation, hopefully we will. But when we're evaluating, we're going to get a numerical answer. But with simplifying, we're just kind of trying to bring together as many of the terms, there's 3 of them here, into our expression. I've got 3 terms here separated by the 1 addition and 1 subtraction into 2 terms, and then I'm done. There's nothing else to do. What I would normally show in class after the first couple of days of combining like terms and getting students used to it, normally what I'll do is I'll leave the expression in its original form, and I'll just circle or box in, or use some kind of random shape to just show the connection, show the like terms. This is 5x and negative 2x, these like terms. Positive 5 and negative 2, come together to make 3. And the positive that's here is for the 7, and it stays there. Okay, when you look for the sign of a term, you always look to the left. This 5 is positive, this 2 is negative, and thus 5 minus 2 is equal to 3. Okay, let's take a look at this one. Negative 3y minus, parentheses, 4y plus 3x. Now hopefully you're comfortable with something called the distributive property, which says when you have a set of nothing there, so let's grab the 3y, the negative 3y, and multiply it through the parentheses. But that negative number that's here is an actual numerical value. It's negative 1. And
to take a negative 1 and multiply it by 8 to get the negative 8x, and a negative 1 and multiply it by the positive 4 to get the minus 4. You can do it either way. I typically just look at that and say, I'm asking for the opposite of these 2 terms. So the opposite of 7x is a negative 7x, and the opposite of a minus 3 is a positive 3. Textbooks often write this in somewhat complicated form. They think of this as a negative 1 times, they use the distributive property, times the 7x, negative 1 times the 7x, and then they think of this minus 3 as a negative 3, and they write this as plus a negative 1 times a negative 3, giving us that positive 3 at the end.
For instance, if we have, let's say, 7x plus 3x squared plus 8x plus 10x squared, combining like terms, well, what does that mean? We need to see terms that are alike. That means the variable part is exactly the same. So in the first term we have a 7x. So we look, is there anything else that has exactly the same variable part? And here it's an x. This is an x squared. That's different. But over here I have an 8x. So these are exactly the same. So if you want, you don't need to write this step out, but I'm going to combine those together. Because it's like, well, I have 7 of these objects and 8 more of these objects. Also, I have a 3x squared. I see if there's another x squared term, and here we are. So by an x squared term, I'm looking for something that has the same variable part. So I can combine those together as well. So I've got 7 of these x's plus 8 more of these x's. That's 15 of them. And I've got 3 of these x squares. That's like a different kind of animal. And 10 of these x squares, that would be 13x squared. And this
negative 1. And you only multiply or distribute through the parentheses what's immediately in front of it. What's right there, right against the parentheses, that's what you multiply through. The negative 3y, that's just going to sit there because it's separated by that minus sign. That negative 1, I'm going to multiply through this parentheses. So we have negative 3y, Negative 1 and 4 is negative 4y. When you multiply a negative and positive number, it comes out to be negative. And negative 1 times positive 3 is negative 3x. So my parentheses are gone. Now I can combine like terms if I have any. And I do. I have negative 3y and negative 4y. So these like terms are going to go together. The x, well, x isn't y, so it's just going to sit there and kind of float down through the rest of the problem. When you start adding or subtracting, you start combining numbers that have the same sign. With addition or subtraction, if you add, you move to the right of the number line. Numbers that have the same sign, or when you're combining numbers that have the same sign, add those numbers and keep the sign. Now, if you're multiplying, it'd be positive, but we're not multiplying. So, negative 3 and negative 4 is negative 7y